So let's begin with question number 41. A series LCR circuit with inductance 10 Henry, capacitance 10 microfarad, resistance 50 ohm is connected to an AC source of voltage 200 sin 100t volt. If the resonant frequency of the LCR circuit is nu naught and the frequency of the AC source is nu, then. So we just have to calculate both the values. If we look at the voltage of source, then 100 is actually omega if we compare it with the standard equation. Now we have to convert this omega into frequency. So for source frequency is going to be omega divided by 2 pi. So this will be 100 divided by 2 pi, which means 50 divided by pi hertz, which is the SI unit of our frequency. So this frequency is the source frequency. Now we have to calculate resonant frequency also. In our question, this value is given as nu. Now the value of nu naught is going to be 1 by 2 pi under root of LC. As we know, resonance frequency is given by this expression. So this is going to be 1 by 2 pi. The value of inductance is 10 Henry and that of capacitance is given as 10 microfarad. So we will write it as 10 into 10 raised to power minus 6. Now in the root there is 10 raised to power minus 4. So minus 2 will come out, and if we take it to numerator, this will be 100 by 2 pi, which again gives us the same magnitude, 50 by pi hertz. So for this particular question and the given values, we can say that both the frequencies are 50 by pi hertz. Let's start with question number 42. There are two lists given. In list 1 there are some physical quantities and list 2 contains their dimensional formula. So we have to calculate dimensional formula, or if we remember them we can directly do this question. But for example, if we want to calculate the value of capital G, we can use this relation, force equals to G m1 m2 divided by r square. So G is having the relation fr square divided by m1 m2. So the dimensional formula of G is going to be mlt minus 2 is that of force, r square means L square divided by m square. So the dimensional formula is going to be m minus 1 L3 T minus 2. So we can easily calculate dimensional formula of a physical quantity if we know the physical relation. Now gravitational potential energy can be simply written as minus G m1 m2 divided by r. So U is, dimensional formula of U can be calculated from this relation, but the thing is gravitational potential energy is also energy. So its dimensional formula can be directly written as m L2 T minus 2. In the same way, gravitational potential is simply energy per unit mass. So we can divide it by mass. So gravitational potential must have formula L2 T minus 2. In the same way, gravitational intensity is simply force per unit mass, force divided by mass. So gravitational intensity should have formula force divided by mass. So m will be missing. We have written force dimensional formula as mlt minus 2. So this will be only LT minus 2. So based on these, gravitational intensity should be matched with third, gravitational potential and potential energy should be matched with fourth, gravitational potential which we have calculated L2 T minus 2 should be matched with first, and gravitational constant which we calculated should be matched with second option. So the correct option here is A should be matched with second, B should be matched with fourth, C should be matched with first. Hence this second option is the correct answer. Let us move on to the next question. Two pendulums of length 121 centimeter and 100 centimeter start vibrating in phase. At some instant, the two are at their mean position in the same phase. The minimum number of vibrations of the shorter pendulum after which the two are again in phase at the mean position is. If we just calculate time period of these two pendulums, then the general relation is that time period is given by 2 pi under root L by G, which means this time period directly depends upon root of length. If we calculate under root of 121, this is going to be 11. So I will write 11. Suppose all other factors can be written as capital T. So this T2 now becomes, it should depend upon under root of 100, so this should be 10t. Now if I want same time so that they can be in same phase, I can easily multiply this with 10 and this with 11, which means the longer pendulum should have 10 oscillations and the shorter pendulum should have 11 oscillations. Hence the answer should be first option. Moving on to the next question. A big circular coil of 1000 turns and average radius 10 meter is rotating about its horizontal diameter at 2 radian per second. If the vertical component of Earth's magnetic field at that place is 2 into 10 raised to the minus 5 Tesla and electrical resistance of the coil is also given as 12.56 ohm, then the maximum induced current in the coil will be. If we write this at a general point where area vector has already rotated with vertical by an angle theta, and the question has given us vertical component of Earth's magnetic field as 2 into 10 raised to the minus 5 Tesla. So the angle, this theta, can be written as omega t, and this is the direction of magnetic field. So flux is going to be dot product of magnetic field and area vector, which will be equal to B A cos omega t. This is for one turn. So for all the turns we can write this flux as by multiplying this expression by capital N. Now EMF can be written as minus d phi by dt. So we will differentiate this expression and this will give us NBA omega sin omega t. And to calculate electric current, we have to divide this expression of EMF with resistance. So we will get NBA omega divided by R multiplied with sin omega t. This is the exact expression for electric current, general expression for electric current in this particular case. But we just need to calculate the maximum value, so we will consider this amplitude. Means I max can be written as NBA omega divided by R. If we put the necessary values, then N is 1000. Magnetic field is given as 2 multiplied with 10 raised to the minus 5 Tesla. Area can be written as pi R square. Radius is simply 10 meters. So 10 square. And omega is 2 radians per second. So we have to multiply this by 2 divided by resistance is 12.56. If we calculate this, then the final result is going to be 1 ampere, which should be the answer to this problem. Moving on to the next problem. A capacitor of capacitance C 900 picofarad is charged fully by 100 volt battery B as shown in the figure. Then it is disconnected from the battery and connected to another uncharged capacitor of capacity 900 picofarad again. The electrostatic energy stored by the system is. Now first, this capacitor has got potential of 100 volt, and if we connect these two capacitance together, out of which this capacitance was at 0 volt while this capacitance was at 100 volt. So the common potential of these two capacitors can be easily calculated using the relation C1V1 plus C2V2 divided by C1 plus C2. If you put values in this expression, then obviously C is same. So we will get the result as V1 plus V2 by 2. Potential of one capacitor was 100 while the other was 0. So the common potential is going to be 50 volt. Under electrostatic conditions, both the capacitors will reach 50 volt potential, which means we can calculate their energy stored. So the energy stored in the two capacitors can be written as twice of, because there are two capacitors, half C 900 picofarad multiplied with V square, which is simply 2500. So this 2 will get cancelled. 9 multiplied with 25 is going to be 225 multiplied with 10 raised to power 100. So this will be 10 raised to power minus 10, 10 raised to power minus 8. This much joules of energy should be stored. If we convert this into 10 raised to power minus 6, the result is going to be 2.25 into 10 raised to power minus 8 joules. Hence the correct answer should be the third option. Moving on to the next problem. A nucleus of mass 189 splits into two nuclei having mass number 125 and 64. The ratio of radius of two daughter nuclei respectively are. We should remember that radius of a nuclei can be given as R0 a raised to power 1 by 3, which means radius of a nuclide is directly proportional to cube root of mass number. So in this particular case, we can say that R1 divided by R2 should be equal to A1 divided by A2 raised to power 1 by 3. Now these two values are given as 125 divided by 64 raised to power 1 by 3, which will simply give us 5 divided by 4. So the answer should be 5:4, third option. Moving on to the next problem. A Wheatstone bridge is used to determine the value of unknown resistance X by adjusting the variable resistance Y as shown in the figure. For the most precise measurement of X, the resistance P and Q, we should know from our practical observations and our understanding of Wheatstone bridge that for accurate results, for more precise measurement, the values should be closer to, the ratio should be closer to 1, as well as the values should be small. Hence, we can simply tick on this second option. Now, for next question, question number 48, the volume occupied by the molecules contained in 4.5 kilogram water at STP if the intermolecular forces vanish away is. We know that intermolecular forces actually vanish when we talk about ideal gases. Now if we talk about ideal gases, then ideal gas equation must be valid. PV equals to nRT. Now pressure multiplied with volume should be equal to mass divided by molar mass multiplied with RT. If we put the values here, then pressure will be atmospheric pressure, which can be written as 1.01 into 10 raised to power 5. Volume of the gas is to be calculated. Now mass is given as 4.5 kilogram. Molar mass of water is 18. If we write it into kilogram, then we have to multiply it with 10 raised to power minus 3. Gas constant value we can put, and temperature, because we are talking about STP, we can add standard temperature 273 Kelvin. And if we calculate from here, then the value of V can be found as 5.6 meter cube, which means our fourth option should be the correct answer in this particular case. For the next question, a ball is projected with a velocity 10 meters per second at an angle 60 degree with the vertical direction. Now we have to pay attention to this statement, 60 degree with the vertical direction. There is a possibility that many students may have taken this angle with horizontal. So its speed at the highest point of the trajectory is, we all know that for projectile motion, if we calculate speed at the highest point of trajectory, and if the angle of projection was theta, then the speed is going to be u cos theta, because this u cos theta speed along x direction always remains constant. So in this particular case, this theta is 30 degree, because angle in the question is given with the vertical. So u cos theta is going to be 10 multiplied with cos 30, which is root 3 by 2. So the answer should be 5 root 3 meters per second. Now we are going to move towards our last problem. Two transparent media A and B are separated by a plane boundary. The speed of light in those media are given 1.5 into 10 raised to power 8 meter per second and 2 into 10 raised to power 8 meter per second respectively. The critical angle for a ray of light for these two media is, first we have to calculate refractive indices of these two medias. So mu1 can be written as C by V1, which means 3 into 10 raised to power 8 divided by 1.5 into 10 raised to power 8, and which will give us value 2, and mu2 can be written as 3 into 10 raised to power 8 divided by speed, which is 2 into 10 raised to power 8. Now this comes out to be 1.5. And if we want to calculate critical angle, then the simple relation is that critical angle should be sine inverse of mu2 divided by mu1. If we divide these two, we will get mu2 is simply 1.5 divided by 2 will give us 0.75. So this is sine inverse 0.75, which means the correct answer should be sine inverse 0.75, the second option. This completes our discussion of this paper, Physics Code Q6. The overall difficulty level of the exam, overall difficulty level of physics section was easy, apart from 3 or 4 questions which were a bit calculative. But student has to be choosy to be able to leave those questions for attempting at the last, or we can say that in this particular paper 11th class questions were around 20 and 12th class questions were around 30. So the more weightage was given for 12th class questions, and overall difficulty level was easy. And if you are thorough with NCERT books and if you are thorough with your theory, then definitely a student who has got good revision will do good in this particular paper. Thank you from Narayana Group.